Hey everybody, Matt Donner, Chief Academic Officer at PyraMind. Take 2 on phasing and beating. Showed you in the last video what happens with two waves get together, 110, 111, and then 110, 112. So what we're going to do now is see what happens when you get 110, 111, 12, and 13 all playing at the same time. Why is this important? Well, it's probably not going to be the case that you're going to have 4 very specific sine waves interacting in a particular piece of music. However, it might be the case where you have one bass synth that's playing A at 110 and another bass synth that you think is playing at 110, but it's really playing at 111 because the oscillator is just slightly out. And when you put the two together, they start interacting in weird ways. Might not even be that obvious. It might be that the bass is at 110, but then a pad is at 220, but really 221. So might be the bass to the bass, might be a bass to the pad, might be a bass to a kick drum. Making sure that all of your frequencies are lining up properly across all your instruments in the key of the song is a really, really important piece of composing and producing, most particularly when you get to mixing. A lot of times people try to get these sounds that they choose to mix right in the mix phase without recognizing that they just don't really interact well on their own. And so you spend hours and hours trying to EQ the tones to make them work, not realizing that the two are never really lined up. They're just slightly out. And they might be out with multiple instruments. So you might actually have a lot of fundamental frequencies that are out in a similar fashion to the way these guys are at. Now, if you guys remember from the other video, we were using this Blue Cat oscillator to kind of watch what the waves were doing. Reminder, here's 110, pumping along just fine, 110 cycles per second. And when we added 111, it started beating and phasing. Notice it got taller at the peak and it got smaller in the middle. So every second, they are both summing, getting bigger, and then phasing, getting lower. And the result is this volume beating. It's literally beating up and down. You also remember that we did 110 to 112, which was doing the same thing twice as fast. You might imagine that 110 and 113 would start doing it in triplets. So 3 times per second. Now that's all very common. Now notice in all 3 of these cases, the peak never really got that peaky. It always stayed within this volume range. Okay. Now watch what happens if we do 110 and 111. But then we add 112. Again, this is the situation where 3 sounds are trying to play the same note, but they're just slightly out of tune from each other. A really good example of this is 2 acoustic guitar parts, where one acoustic guitar is just slightly out of tune from the other. Go to add a third one and find that it's out of tune from the other 2, you're going to see something exactly like this. So here's the 3 of them together. So as you can hear, they're kind of doing 2 levels of beating. There's a wop, 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 wop. There's a smaller beating and then a larger beating. The larger beating happens every second where all 3 line up together. But in between, one of them is off by a second and then one of them is only off by a half second. And so you can hear the 2 levels of beating as 110, 111, and 112 all interact together. Notice now that when they sum, they're no longer down here. They're summing towards the top. Now remember that each of these signal generators is generating a signal at 6 dB below dBFS, or 6 dB down from digital 0. Now even though that's 6 dB per sound, when we start adding 3 together, we get really close back to 0. Now what I'm going to do is I'm going to turn 113 on and listen to what happens when all 4 sounds interact. You might imagine you're going to get a few different levels of beating and that the top is going to be really, really loud. So we'll wait for our demo version Blue Cat oscilloscope multimeter to come back from demo mode. There it goes. And here we go. It's a little faint to hear, but there's actually 3. It's da dun dun ba dun dun ba dun dun. So 3 times per second they're going through 3 levels of phasing, summing. And again, the summing now is way up at the top. The beating is way down at the bottom. And all 3 are, in fact in this case, all 4 are interacting at multiple times per second. Now, that's what happens when multiple waves get together and start interacting. In this case, not so positively. So what I'm going to do is go over to my friend the phase scope and show the same thing. But now what I'm going to do is I'm going to start panning them. I'm going to take 110 all the way in the left, 111 a little bit in the left, 112 a little bit in the right, and then 113 all the way on the right. And now you can see what's going on. Look at those meters freaking out here. They're going left, right, up, down, boom. So every second they're phase canceling and shifting their phase across the stereo spectrum. You can see it here, right? Left, right, left, right, left, right, left. Same thing with the phase scope. It's kind of really confused as to whether it's in phase or out of phase, and that's all happening multiple times per second. You're going to get this kind of reaction when you have a couple of synths together that aren't quite in sync. That's not necessarily a bad thing. A lot of guys take synth sounds and they do a bass sound, and then they take the left and sort of pitch it down just a hair, and the right and pitch it up just a hair to make this phase interaction and this beating sound, and to give a single kind of boring mono bass sound width and interest. So there's going to be a lot of activity within the sound, all based on the premise of phasing and beating. Till next time, Matt Donner, Chief Academic Officer at Pyramide, saying, hope you enjoyed this.